Hello everyone, myself Pradhumn, working as assistant professor, Department of Community Medicine in Santosh Deemed University, Ghaziabad. Today I am going to discuss basic statistical concept. Statistics is majorly divided into the two categories, descriptive statistics and inferential statistics. Descriptive statistics organize, describe and summarize data using numbers and graphical techniques. Inferential statistics is concerned with drawing conclusion about the population from the analysis of a random sample drawn from the population. Inferential statistics also concerned with the precision and the reliability of those inferences. A population is a complete set of observation or the entire group of objects. A sample is a subset of the population. The sample should be representative of the population. You can obtain the representative sample by collecting a simple random sample. Parameters are numerical values that summarize characteristics of the population. Parameter values are typically unknown and are represented by Greek letters. Statistics summarize characteristics of sample. We use letter from English alphabet to represent sample statistics. We can measure characteristics of a sample and provide the numerical values that summarize those characteristics. We use statistics to estimate parameters. Variables are characteristics or properties of the data that like different values or amounts. A variable can be independent or dependent. In some cases, you select the values of an independent variable in order to determine its relationship to dependent variables. Variables are also classified according to their characteristics. They can be quantitative or categorical. The data that consists a count or measurement is quantitative, and quantitative data can be further classified into two types, discrete and continuous. Discrete data takes only a finite or countable number of values. Continuous data has infinite number of values and no breaks or jumps. Categorical or attribute data consists of variables that denote groupings in the labels. There are two main types of categorical data type, nominal or ordinal. A nominal category variable obtained by ordering within its group or categories. With ordinal categories variable, the observed label of the variable can be ordered in the meaningful way that implies differences due to magnitude. A variable's classification is its scale of measurement. There are two scales of measurement for categorical variables, nominal and ordinal. There are two scales of measurement of continuous variable, interval and ratio. Data from an interval scale can be ranked, ordered and has a sensible spacing of observation such that difference between measurement are meaningful. However, interval scale lack the ability to calculate the ratio between numbers on the scale because there is no true zero point. Data on the ratio scale includes a true zero point that can therefore accurately indicate that the ratio of the difference between two spaces on the measurement scale. The appropriate statistical method for the data also depend on the number of variables involved. In univariate analysis provides techniques of analyzing and describing a single variable at a time. Bivariate analysis describe and explain the relationship between the two variables and how they change together. Multivariate analysis examines two or more variables at the same time in order to understand the relationship among them. In descriptive statistics, a data distribution tell you that what value your data takes and how often it takes those values. You can calculate descriptive statistics that measure location in your data. Statistics that locate the center of the data are measured of center tendency. These includes mean, median and mode. Percentile are descriptive statistics that give you reference point in your data. A percentile is the value of the variable below which the certain percentage of observation fall. The most commonly reported percentile are quartile, with break which break the data into the quartiles. There are several descriptive statistics that measure variability of your data: range, interquartile range, variance, standard deviation, coefficient of variation, etc. Now coming to the graphical representation of the data. A histogram is a visual representation of the frequency distribution of your data. The frequencies are represented by the bars. The normal distribution is a common theoretical distribution in the statistics. It is bell-shaped with the value concentrated near the mean, and it is symmetric around the mean. The standard deviation sigma determines how variable the distribution is. Underlying the normal distribution is the mathematical function named the probability density function. To check the assumption that your random sample has normal distribution, you can plot a histogram. You can also look the statistics summaries of your data that closer skewness or kurtosis are to 0, the closer your data is shaped like a normal distribution. Skewness measures the tendency of your data to be more spread out on one side of them than on other. It measures the asymmetry of a distribution. The direction of the skewness is the direction to which the data is trailing off. The closer of skewness is to 0, the more normal or symmetric in the data. Similarly, kurtosis measures the tendency of the data to be concentrated toward the central or toward the tail of the distribution. The closer kurtosis is to 0, the closer that the tail of the data resembles the tail thickness of the normal distribution. The negative kurtosis statistics means that the data has lighter tail than in a normal distribution, and it is less heavily concentrated above the mean. This situation is called, this is a plotokurtic distribution. A positive kurtosis statistics means that the data has heavier tail and it is more concentrated above the mean than the normal distribution. This is the leprokurtic distribution, which is often referred to as the heavy tail and also as an outlier prone distribution. A normal probability plot is another way to visualize and assess the distribution of your data. In the vertical axis represent the actual data values, the horizontal axis displays and expect percentiles from the standard normal distribution. The normal reference line along the diagonal indicates where the data would fall if we were perfectly normal. A box plot makes it easy to see how spread out the data is and if there are any outliers. Confidence interval for the mean. A point estimator is a sample statistics used to estimate the population parameter. A statistics that measure the variability of your estimator is the standard error. The standard error of the mean measures the variability of your sample mean. It is an estimate of how much you can expect the sample mean to vary from the sample to sample. The distribution of the sample mean is the distribution of all possible sample means from the population. The distribution of the mean is always less variable than the data. The interval estimator is another way to estimate population parameter. It incorporates the uncertainty of that arise from the random variability. Confidence interval are the type of interval estimator used to estimate the population mean while taking into the account the variability of sample mean. The central limit theorem states that the distribution of the sample mean approximately normal regardless the population distribution state. It is the sample size is large enough. If the sample size is large enough. Hypothesis testing. A hypothesis test used to sample data to evaluate a question about the population. It provides a way to make inference about a population based on the sample data. There are 4 steps conducting a hypothesis test. The first step to identify the population of interest and determine the null and alternative hypothesis. The null hypothesis is denoted by H0 is what you assume to be true unless proven otherwise. It is usually hypothesis of equality. The alternative hypothesis, which is denoted by HA or H1, is typically what you suspect or the attempting to demonstrate. It is usually a hypothesis of inequality. The second step in the hypothesis testing is to select the significant level. This is the amount of the evidence need to reject the null hypothesis. In a common situation, significant level is 0.05, that is 1 chance in 20 we take. The third step to collect the data. And the fourth step is to use decision rule to evaluate the data. You decide whether or not there are enough evidence to reject the null hypothesis. If you reject the null hypothesis when it is actually true, you made a type 1 error. The probability of committing a type 1 error is denoted by alpha, which is alpha is the significance level of the test. If you fail to reject null hypothesis and it is actually false, you made a type 2 error. Type 2 error, the probability of committing a type 2 error is beta. Type 1 and type 2 error are inversely related. The power of the statistics test is equal to 1 minus beta, that is 1 minus type 2 error. The difference between the observed statistics and the hypothesized value is the effect size. A p-value measures the probability of observing a value as extreme as one observed or more extreme. A p-value is not only affected by the effect size but also affected by the sample size. So this is the basic introduction of the statistics terms, basic concept of the statistics. Thank you for listening me. Thank you.